All right, every single time you power on a Linux machine, you're kicking off this incredible, super fast chain reaction. So in this explainer, we're going to break down that entire journey, from the moment you hit the power button all the way to that login prompt. Seriously, understanding this process, the system architecture, is absolutely fundamental to mastering Linux.
You know, it seems so simple, right? You just press a button. But in those few seconds, a whole lot is going on that decides if your system even starts. For a Linux admin, this isn't just a fun fact. This is your troubleshooting roadmap. It's how you really get what's happening under the hood.
So, first things first, it all starts with the foundation. Before any of your apps can do anything, the software has to figure out how to talk to the physical hardware. And that whole conversation is managed by the single most important piece of the entire OS, the Linux kernel. Think of the Linux kernel as the system's brain. It's the core program, the first major piece of software to load, and its entire job is to be the middleman between your software and your actual physical hardware. It manages everything, the CPU, the memory, all of it. And here's the key takeaway. When you run a program, it doesn't talk directly to your processor. No way. It talks to the kernel. And the kernel then translates those requests into instructions the hardware can actually understand. It's this brilliant layer of abstraction that just makes everything else work. Now, this is where the kernel's design gets really, really clever. I mean, imagine if the kernel had to have every single hardware driver ever created built right into it. It would be enormous. So instead, it uses modules. You can think of these as on-demand, plug-in drivers for, well, everything. Your network card, your webcam, you name it. And as a Linux admin, you've got tools to see this in action. For example, is your new graphics card acting up? lsblk will tell you if the system even sees it. Wondering what driver your Wi-Fi is using? lsmod shows you exactly which modules are loaded. And of course, lsusb is your best friend for anything you plug into a USB port. And if you want to get an even deeper look, Linux gives us these incredible virtual file systems. Now, they aren't real files on your disk. Think of them as a live window, a dashboard right into the kernel's brain, showing you what it's thinking in real time. Proc is all about processes, and sys is all about hardware. Okay, time for a little pop quiz. You just got a brand new webcam, you plug it in. What's the very first command you're going to type to make sure the system has even recognized it? You got it. It's lsusb. Since pretty much every webcam connects via USB, that's the perfect tool for the job. You run that and you should see a new line pop up for your webcam. That's your proof that the kernel sees it and is loading the right stuff. Okay, so we know all about the kernel now. Let's hit the rewind button and go all the way back to that first moment. We've just pressed the power button. Let's walk through the step-by-step sequence that brings our entire system to life. You can think of the boot journey as a 4-stage relay race. First up is the firmware. That's your BIOS or UEFI, which does a quick hardware check called a post. Once that's good, it passes the baton to the bootloader, usually Grub. The bootloader's only job is to find the Linux kernel and load it. Then, the kernel takes over and finally kicks off the very first program, a process called init. Now, hang on, there's a little chicken and egg problem here, right? How does the kernel load the drivers from the hard drive if it doesn't have the driver for the hard drive controller yet? The answer is init ramfs. It's this tiny, temporary file system loaded into RAM that has just enough drivers to let the kernel see the main hard drive and continue booting. It's a really clever solution. All right, another quick check. Looking at that sequence, which one of those stages does that very first hardware check, the post? Yep, the firmware. And that is so important to remember. Before the bootloader, before the kernel, before anything, the low-level software on the motherboard itself has to give the A-OK that the basic hardware is working. So, the kernel's loaded and running. It's done its job. Now it does one last crucial thing. It starts that process we mentioned, init. You can think of init as the parent of every other process on the system. Its job is to start all the services and get the machine into a state where you can actually use it. Now, for the LPIC 1 exam, you've got to know about 2 generations of init. There's the classic, old-school way called sysb init, which uses these numbered run levels. But the modern standard you'll find pretty much everywhere now is systemd. Its big advantage is that it's way faster, because it starts services at the same time using things called targets. And this table right here, this is basically your Rosetta Stone for the exam. It shows you exactly how the old run levels map to the new systemd targets. So for example, the old run level 3 for a command line system is now just multi-user target. And run level 5 for a full graphical desktop, that's graphical target. Knowing this mapping is a must. Okay, with that in mind, let's say you're on a modern desktop system and you need to switch to a text-only mode. On the fly, without rebooting, what command are you going to use? And there's your answer. systemctl isolate multiuser.target. That keyword isolate is super powerful. It tells systemd, hey, stop everything that's not needed for the multi-user target and start anything that is. It completely changes the system state without a restart. All right, let's bring it all home. Understanding these concepts isn't just about passing a test. This stuff is the foundation of being a really effective sysadmin. It's like having admin superpowers.
So here's your quick and dirty cheat sheet. The kernel is the core translator. Kernel modules are the plug-in drivers that give it flexibility. The boot process is that four-step race, firmware to bootloader to kernel to init. That init process is always process ID 1, the parent of everything. And today, we use systemd targets instead of those old run levels. Got it?
And here's why it all matters. When a server goes down and won't start, you're not going to get a friendly error message. Nothing. You have to know this sequence to figure out where it failed. Did the firmware not see the hard drive? Did grub fail to load the kernel? This knowledge is your #1 troubleshooting tool. So I'll leave you with this final thought. Armed with this architectural map of how a Linux system boots, what is the first thing you investigate when a server just goes dark? Where do you begin? Thinking through that sequence is the first step to thinking like a real, seasoned Linux pro.